one computer will be working and two of the computer is not working and only one computer is working, but you require at a time two computer to work. So what will happen? We will generate a warning, and that is called as low level warning. In low level warning means what? One of the computer is in working state, one of the and two of the computer are in idle state. So idle state because they are not working. So this creates a warning, and there is a serious warning when all the three computers go bad. Okay, so now you have to understand this question. I will call the three variable. Okay, I hope you have noted down the question. I will read the question again. A NASA system consists of three computers, two of which are online at any given time. If two of the computers are online at any given time, means it is all fine and there will be no warning generated. So the system uses three computers to ensure the safety in the spacecraft operation through redundancy. Redundancy means what? We keep extra so that our operation never stops. Okay. So if one computer experiences a problem, it is taken offline and another, the standby computer, is brought online. Now self-checking diagnostic determine each computer's operating status and generate an output in the event of failure. So you will have an output with respect to each computer, which will be made one if my computer fails. Okay, I will make a truth table, you will understand it better. Now when one computer fails, it must be switched offline, and when no more than two computers are available at any given time. So at any given time you have to get the work out of two computers only. Whether two only are available or three are available, at a given time only two computers will be working. Now the question says design the control logic to connect or disconnect the computer. Okay, and if two computers are unavailable, this is a warning. Okay, this is a warning. If two computers are unavailable, two computers are unavailable means one computer is still working. Okay, but you need to generate a warning and allow the third computer to come online. This is low level warning when at least one computer is available to work. But if all the three computers become unavailable, then a more serious second warning will be generated, which will be like to invoke emergency procedure. So this warning when three computers are unavailable is a serious warning. So high level warning. Okay. Now I hope you have understood the question. Now let me show you how to solve this question. Now you know that there are three computer systems. So I will call as computer 1, computer 2, computer 3. There are three computer system. Okay. And there is a logic for each computer to get connected or not connected. Okay. So this O1, O2, O3 is what for? O1 is to connect C1, O2 is to connect C2, and O3 is to connect C3. Okay. So these are switching logic. O1, O2, O3 are the switching logic, or you can say these are the intermediate signal. Okay. What else you want? You want to generate a warning signal. Now, one warning signal, W for warning, one warning signal is when one computer is working and two computers are unavailable. This is a lower level warning. Then you have a serious warning when no computers are available to work. Okay. Now I hope you people know what do you mean by active high logic or active low logic. Okay. See, you people can write down that C1, C2, C3 are the variable used to show computer. Okay. And if C is 1, that means the computer has failed. Okay. If C is, this is very important to note. If C is 1, that means that computer is failed. Computer is failed. So you have to give such instructions when you are designing a control logic. So that means what? 1 means fail. So if I say 0, 0, 0, what does that mean? What does that mean?
All the computers are available.
All the computers are available. If C1, C2, C3 is 0, 0, 0, that means all the computers are available. Now, which computer you will choose to work? You can choose any one. So you can make O1, O2 as 1, 1, or O2, O3 as 1, 1, or O1, O3 as 1, 1. Anything is fine. It is user's choice. So let me make O2 and O3 as 1, 1. Okay. Now, when I have 3 computers, how many possibilities will be there that one of it will fail or something like that? How many rows will come with 3 variable? How many will come? You are not answering, I am writing simply. There will be 8 possibilities, right? There will be 8 possibilities. Now, if 3 variables are there, 8 possibilities there, we need to make a truth table for this 8 possibilities because there are 3 computer systems. If we had 4 computer systems, there would have been 16 possibilities. Now, when I say that all the 3 computers are available, none of them have failed, I chose computer 2 and computer 3 to work, and I did not choose computer 1 to work. And do you think any warning is generated? No warning generated because both we have 2 computers to work and 1 computers for standby. We have that. Now coming to the second row. What does the second row mean? Quickly. What second row means?
C3.
C3. C1, C2 is available.
Yes, C1, C2 is available. C3 is not working.
Not working.
If C3 is not working, I can't connect it to work. It will not work. But my C1 and C2 will work. Do you think warning need to be generated?
No. No.
Why? Because my 2 systems are available to work and they assume that the system which is not working is under repair. So they will not bother about this. So no warning generated. Same goes true with the third case when C1 and C3 are available to work and C2 is not available to work. Now coming to the fourth position. Only C2 and C3. C2 and C3 are, what happened to C2, C3? C2, C3 has a problem. It is failed. C2, C3 is failed. C2, C3 failed means it is not available to work. Only one computer is available to work. Do you think warning need to be generated?
Yes, ma'am.
In our third case, warning was not generated, but now warning is generated. Low level warning. It is trying to say only one computer is working. Warning, please do it fast. Please make other system to work fast. Coming on to this one. Next case, 2 computers are available, right? 2 computers are available. 1 computer is not available. No need of any warning. Coming to this case again for 5. What is happening? Only 1 computer is available, 2 computers are not available, warning need to be generated, but not a serious warning. This one, second last one, only 1 computer is available to work, C1 and C2 is not available to work. Because only 1 computer is working, you have to generate a warning. And not serious warning. This is the last case when all the 3 computers are not available to work, and you have a serious warning. You don't have a low level warning. You have a serious warning, right? So this is your truth table. Now you have to quickly tell me, because time is up for the class. You have to quickly tell me what is W1 and W2, both are function of C1, C2, C3. You need not bother about O1, O2, O3 because that is an intermediate signal. That is an intermediate signal. Okay. C1, C2, 3 is input. W1, W2 is output. Okay. Now, what is W1 equal to?
3, 5, and 6.
Yes. 3, 5, and 6. And what is W2 summation?
7.
Only 7. So you can make an equation of it, right? And you can make a circuit of it. Okay. Now we are doing only the computer system. See, if somebody says, no, I don't want function of C1, C2, C3. If somebody starts saying, I want this only, I want the intermediate thing only, then what will happen? Quickly. What will be W1? Tell me. O1, O2, O3. Now it is function of this, not this. It is function of this intermediate signal. So W1 is high for 3 cases. And what is these 3 cases? 4. And what is this? 2. And this is 1, right? 4, 2, 1. And what is warning 2? That is a 0. Okay. What I am trying to say is, there are 2 ways of seeing this. Either this is one way, this is second way. Okay. So if you are told, if your block diagram says that C1, C2, C3 is your input and output is W1 and W2, then this is the case. If somebody says, you please design a system in which I am giving you the signal of O1, O2, O3, then this is the case. Are you understanding this? This is NASA system of 3 computers. Okay, NASA system of 3 computers. Is that clear? Now next is your conveyor belt. We have 2 problems of this conveyor belt. Again, this has to go to the next class only.